Hello everyone,
Hello everyone.
welcome to
Hello.
Untitled.
Welcome to
Hello everyone,
Hello everyone.
welcome
Hello
to
everyone. Hello everyone.
beginner's course. We are going to learn first what's a machine learning and what are the types of a machine learning. Machine learning evolved from computer science that primarily studies the design of algorithms that can learn from speech. To learn, they need data that has a certain attributes based on which the algorithm try to find out some meaningful predictive patterns from the input data. And then finally, it generates a target output. The classification of machine learning is generally of four types. They are a supervised machine learning, unsupervised learning, reinforcement learning, and semi-supervised learning. In a supervised learning, we have input data people. We have learning in real market. On the basis of required output, we can classify machine learning algorithms in three types: classification, regression, and clustering. In classification, we have a certain type of output or a finite number of outputs. In a regression, we have a continuous type of the outputs. And in the clustering, we do not have any special type of the output. I mean, finite amount of target output, but we do not know how many output it is going to produce in the clustering. But in the classification, we know before training the algorithm that there are a finite number of classes in the output. But in the clustering, we get after the training our algorithm. And this clustering is unsupervised learning. There are many tools available for machine learning algorithms like scikit-learn, TensorFlow, Keras, K-train, and the PyTorch. So we'll be using kind of all of these libraries or Python packages in our course, and we will be utilizing these things very beautifully in this course. These are some of the famous algorithms, although there are many more type of the algorithms, but in general, these are the famous algorithms for the beginners to get started with the machine learning. I have another course on advanced machine learning, and that is specialized in advanced NLP course, and there I have described a little advanced algorithms in machine learning, and I have also described how you can deploy your machine learning algorithms on the internet. You can go to my profile and then you can enroll in that course. The basic type of the algorithms are regression, logistic regression, SVM, decision tree, and the random forest. A regression is a regression type of the algorithm where we have a continuous type of the output. A logistic regression, SVM, decision tree, and the random forest, although these can be also used as a regression. So the mostly we will be learning about these four type of the algorithms at the first, and then we will be also learning CNN, RNN, and LSTM GRU transformers later in this course. There are many types of the clustering algorithms such as the k-mean clustering, k-shift clustering, density-based spatial clustering of applications with the noise, expectation maximizations clustering using Bayesian mixture models. So these algorithms will be also discussing later part of this course. These are the model training, and this is the schema how in general we train our model. Let's say we do not have a data. So the first of all, we need to collect the data. Thereafter, we clean the data. All right. And then we build our model. Thereafter, we train it and then we validate it. And then we test it. If there is any error, then again we train it, validate it, and the test. Once model is finalized, and suppose that at this place you have got your final trained model, then at the stage of the deployment, then we can also do directly feed this data which is coming from data cleaning directly into the model testing, and then we can again test our model. All right, and thereafter once this testing is done, then we can deploy our model. And if you see it at the abstract level and at the stage of the deployment, it is kind of, let's say you have here level data and training code. So this is kind of the data which you want to train. Then you build the model. Once model is built, then you write an application code for your model deployment, which runs at the server. Thereafter, it is once it is deployed, once it is deployed in the production, then you call this model prediction using HTTPS request, API requests, and then finally you receive the data or predicted data. All right. So during the training, we actually divide our data in two sets. It's a training set and test set. Sometimes we also divide this data in a three set: training set, validation set, and test set, as we have already seen it in the previous slide. So the training set is a subset of the data which we use to train the model, and test set is the subset of whole data which we use to test the model. And similarly, if we talk about the validation, we can say that the validation is a set of the data or a subset of the data which we in general use to validate our model. All right, perfect. So the one more thing you need to pay attention here is that, let's say once you have splitted your data in training set and test set, you should also make sure that your test set meets the following two conditions. Your test set should be the large enough to yield statistically meaningful results. All right, that mean it's like that. It's not like that. I split your data in just two or three instances of the testing set. Uh, Split your data in at least 10 to 20% of the data so that you can actually test your data in a larger variety, of your data. Then the second step is representative of the data set as a whole. That's mean whenever you get this test set, all right. So in this test set, you should have all the type of the data as most as you can try. It means that, let's say, if you have the two classes, class 1 and the class 0, and if you put all the data of class 1 in the test set, then you are not going to you are not going to good accuracy. In fact, even though if you get the good accuracy, but that doesn't mean that your model is robust because you have just placed a single type of the labeled data in the test set. So you should try to put a balanced type of, that's mean it should include all the type of the data, all the type of the data in the test set. In other words, you can say here, don't pick a test set with different characteristics than the training set. All right, perfect. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson. Hi everyone. Welcome to linear regression and data analysis on a Boston housing dataset. We will be doing here house price prediction on a Boston housing dataset. But before we get started with house price prediction, we need to understand what is linear regression and what are the use cases of linear regression, and thereafter we will learn how we can build a model for a linear regression. So let's suppose that you are a real estate agent and you want to predict the house price. But you may ask a question that why you want to predict the house price? Because you are a real estate agent, meaning customer and client coming to you, and you want to sell a lot of house. But you always want to, whenever you need to sell a house, but before that you need to also buy a house. And for your own purpose, when you buy a house, you have to know that what will be the estimated cost of that particular house in that particular area. So what you can do, you can collect data set around that city of the house prices, and thereafter you can write linear regression algorithm to predict the house price, or you can say that the house price of any house in that area. So in the same way it works, and you want to make it there an automated system which can actually predict the house based on the various input such as house locality, what is the area of that house, and there is how many number of rooms in that house, how far it is from city, how far it is from highway, and how far it is from river, all those things you can take as an input feature. Thereafter, you can identify that what will be the expected price of that particular house. So in this regard, we will be using here a supervised machine learning algorithm. There are two type of machine learning algorithm: supervised machine learning algorithm and unsupervised machine learning algorithm. So linear regression is a part of actually supervised machine learning algorithm. All right. So you may also ask a question, where can linear regression be used? Linear regression is something like that. There is independent variable and you want to predict their dependent variable. So this y is dependent variable which can be seen as a house price, and x is independent variable which can be seen as number of room in a house, number of bathroom, or you can say the total square feet or square meter area of that particular house. So this one is independent. And these dots are actually actual price of a house, and this red line can be seen as a regression line, or you can say a fitted line. The linear regression is very powerful techniques and it can be used in various cases, such as you can also predict, or you can say that you can forecast a sale in coming months or in coming years. You can also gain insights about the customer behaviors. You can understand the Twitter popularity. You can understand the stock prices, etc. So we'll be discussing these things in the coming lecture. So this is all about in this lesson. Thanks a lot for watching it. All right, now let's go ahead and try to understand what is linear regression and how we can make its model. Moreover, we need to understand how linear regression model works. First of all, as you know that regression is very important, very important machine learning model where you want to predict target variable as a continuous variable. Do remember, classification, in classification you do a classification where a target variable are categorical variable. That's when the target variable have only some limited values like 1 2 3 only, like the classes. It's like a human, bird, animal, etc. But in the linear regression you have a continuous output. So there you have to predict some number in the output. So there we use a linear regression. The linear regression works something like this. There you have data which is treated as input data, which you can also say that the input feature, and the total number of columns present in the input is known as total dimension of a feature. Dimension of feature means how many columns or how many unique number of features present in the data. To remember, it's a unique. If there is duplicate features, then you need to remove those duplicated features. Then you have this data. Thereafter, you can do the pre-processing on the data, like the data cleaning, like like the duplicate removal, and if there is null values, then you can impute those null values. So this data pre-processing you can do. Thereafter, you have to feed this data into a regression. So this regression learns a relationship between the y and x. So their y, as I have already told you that this y is the target variable and x is the input which is independent variable. So this regression model learns the relationship between the independent variable and dependent variable. Once this regression model learns the relationship between x and y, then it is able to make here intelligent decision. So in intelligent decision, It can predict your house price, it can predict stock price, it can predict the Twitter popularity. So these things it can predict. Do remember one more thing, the Y prediction will be always continuous. A continuous variable means you have a number which have an infinite resolution, like a number 1, 2, 3, but in classification you have a fixed number of levels. But in regression, you can achieve infinite resolution like 1 to 3, 1.1, 1.2, or 1.11, 1.101 means you can predict any value in a number range. All right, perfect. So this is all about in this lesson. In the next lesson, I'll show you what are the use cases of a regression. All right, now let's go ahead and try to understand what is the regression example. Regression can be used in a stock price prediction as well. There we predict the stock price of a particular company's stock. There you have a dependent variable which is x, and in the form of x you can take many input variable, like you can take the recent history of a stock price, news events, uh, and thereafter you can also take the recent history of opening and the closing stock prices of the competitor, and any political decisions are made in those area, and these things you can take into account, and thereafter you can also take the history cases of the competitor. Those things you can find as a dependent variable. Thereafter finally you can predict the target variable, which is a stock price of a particular company. Do remember, in case of stock price prediction, only a company's data is not sufficient. You need to also get the data of a related company. Like, let's say, if you want to predict if you want to predict here the stock price of Google, then you have to also know the stock price of the other related companies, top 10 companies like Facebook, Apple, Amazon, and Tesla, etc. Why these things are important? Because when you want to predict the Google price, the Google is actually, the dependent. It's not the dependent, but overall the stock price goes in the same direction as other companies' stock price goes in which direction. So the moreover, if you include the data of other companies as well, then you will be able to get the better stock price prediction. But in the last, you have to actually include only the related company. For example, if you want to predict the stock price of the Tesla, then you can take those companies which are making rocket, which are making automatic vehicle. So, and all those companies you can take, and then finally you can predict the stock price of the Tesla. Although the Tesla doesn't make rocket, that is the SpaceX, but still, since this is Elon Musk company, so you may include these companies. So the another example is tweet popularity. You can also use the regression model in tweet popularity. You can estimate the number of people who will retweet a particular tweet based on the input feature. The input feature could be like what is the sentiment of that tweet, for which you want to calculate the how many number of people is going to retweet that tweet. You can take the input feature how many followers of the of the person who has retweeted, and how many followers of the person who has actually tweeted this, and how popular hashtag is there, the tweet which has been included there. Thereafter you can also take the other input features like if it is male, female, and if it is celebrity or not, if it is related to any political party, and if the Twitter have any political sentiment or not, is it environmental sentiment or what type of the sentiment? This tweet have a positive or negative sentiment. So these things you can include as the input feature. Thereafter, you can estimate that how many people are going to retweet that particular tweet. The another important application of linear regression which we are going to use in this lecture, that is the real estate. In real estate, you can use the linear regression to predict the house prices. In the form of the input, you will be having house attributes as the input feature. So what could be the house attribute here? The house attributes are how many number of rooms are there in that house, how many bathroom is there, what is the area of that house, how far it is from city, how far there is a hospital around that house, how far it is from a highway, and what is the literacy rate around that house, what is the tax, and all those things you can take into the account for the house price prediction. So once you get all these features, then you need to feed these features into the model. Once model is trained, now you will be able to predict these house prices based on your based on your input. All right, perfect. So this is all about in this lesson. Thanks a lot for watching me. I'll see you next lesson. All right, let's go ahead and discuss what is regression type. How many regression types we have? We have two types of linear regression. One is simple linear regression and another one is multiple linear regression. And if we talk about types of regression, then you can say that simple linear regression, multiple linear regression, and non-linear regression. But here we are just looking for linear regression type. In fact, so I should say here this linear regression type. So these are the two types here, simple linear regression and multiple linear regression. So what's the difference between these two types of the regression? The first one, which is simple linear regression, it is actually one variable linear regression. That means in an input, you have only one variable. And here, for example, only one variable, which is house size, is shown, and based on only one input feature or only one input variable, we are trying to predict the house price. All right. And if we talk about multiple linear regression, then we need more than one input variable. That means that is a multiple linear regression. All right. So this one shows that here there is only one variable and then predicted output. Thereafter, another one we have here intercept and better fit. So what is this? This says that how we are going to get the perfect line. All right. So how we are going to get here good fit, which is also defined as goodness of fit. A goodness of fit means how well or how good your model is fitting on given data. And this plot is showing you that how your model error is decreasing. For example, this blue line, you see this blue plane actually. So this blue plane is actually a loss function. So this blue plane is a loss function, and as we are training our model, our loss is decreasing, decreasing, and decreasing. So this one is like descending a hill. All right, that's mean you are going downward of a hill, and then you are here going upward of hill.
So you need to find here a valley. So the valley is this one. Do you see this plane is there? So the valley is this one, and this will be here a minimum error and minimum loss. So when you get a minimum loss or minimum error, then you say that your model has now fit the data. Simple linear regression can be defined as something like this. There you have an input variable which is x, and these are the regression coefficient. So this beta 0 is actually intercept. Alright, this beta 0 is intercept, and the beta 1 is a population coefficient, or you can say beta 1 is the coefficient of a regression. It depends what type of the input we are actually giving to our model to predict the output. So this beta 1 is the coefficient of that particular variable, and thereafter you have here epsilon I, which is actually a random error. So this one is equation of a simple linear regression. In a simple linear regression, you have only one input as a feature. But in the multiple linear regression, you have multiple input as the feature. That means you have multiple independent variable, or you can say you have a more than one independent variable as the input. Alright, this is also called as a polynomial regression as well, because we are including here a multiple input in a final output prediction. And if you notice here, in a simple linear regression, we get a straight line. But if we fit here a multiple linear regression, then we may get here a polynomial line as well, because we are using here a multiple input as the input feature. For example, if you notice here, we are using house size, and we are also using here number of bathroom in that house. So this one is the two variable. You can use as many as variable you want. It will be always a multiple linear regression there. And this price, their price is a house price prediction. And one more thing you may notice here, earlier we had here a simple line, but if you have a multiple input in your linear regression model, then you are going to fit here a plane. Alright, so in a single input you fit a line, but in multiple input you fit a plane. So with the two input you have a two-dimensional plane. So you are fitting this plane, and these actual house prices lies on these plane. Alright, that's how it works. You can include more number of features, so it's a kind of the unlimited number of features. As many input feature you have, you can include, and total number of features are equal to the total number of dimensions of this fitted plane. Alright, perfect. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson. Hi everyone. So we are now going to learn what is the Boston housing dataset and how we can load Boston housing dataset in our Jupyter notebook. So the Boston housing dataset have total 506 number of rows, and there are total 14 columns, and out of those 14 columns, 13 columns are an input feature which we will be using to predict the final output, which is the target output. These are the column which is present in the Boston housing data set. These columns are crime, indus. So before we describe all these things, let's go ahead and first load this Boston housing data set. So the first of all, you have to install the packages here, R packages. The R package which we need here, that is the mass package. So it will install this R mass package in your computer. Thereafter, we are going to load here library. Alright, so this mass package is loaded in your notebook. Thereafter, we can read it like this: Boston is equal to Boston. All right, so this Boston data set is read into a Boston variable. And if you see the head of this Boston, you will notice it has total number of 14 columns. Out of these 14 columns, these first 13 columns are actually input feature. And based on these first 13 columns, we will be predicting here the target output, which is the median value, which is the house price. And to understand the meaning of these column, we need to visit here, we need to visit this description here. The crime is a per capita crime rate around the town, and GN is a proportion of residential land zone for lots over the 25,000 square feet. So it's like that. What is the proportion of residential land there? Indus is proportion of non-retail business acre. This charge is Charles River dummy variable. Their NOx is nitric oxide. So it's like nitric oxide around the house. There you have RM, which is the average number of rooms. Then you have age. Age shows that what is the age of house. DIS, you have the weighted mean of distance to a 5 Boston Employment Center. Thereafter, you have here radius, it's the index of accessibility to the radial highway. Thereafter, you have the tax, full value property tax rate. Then you have here a PT ratio, which is the people teacher ratio by the town. So this says that what is the ratio of people living around that house and the teacher ratio. The more number of teacher presents around that house, more number of teacher presents around that house means there the better there you can say the better accessibility for the education. Then this black says that the portion of blacks by town. Then you have L stat, which is the lower status of the population. And the lower status of population means what is the percentage of the population, poor people living around that town and the house. Then the median value of owner occupied homes. So the moreover, what is the median value of house price? All right, and it is the $1,000. That's when the scale of these median values are $1,000. So the first house price is 24,000. Another one is the 21.6 thousand. There you have a 34.7 thousand, and so that. All right. So based on these input features, we will be predicting the target output. And you can also see the structure of the Boston housing data set. This structure says that most of, in fact, all the columns, all these columns are integer and number. That's been the numerical column. You can also get those from here as well. Thereafter, you can also get the statistical summary of this data set. The summary Boston. So the summary Boston says that these are the statistical summary. And in statistical summary, if you notice the maximum value for crime is 88 and lowest value is 0.006, which is almost none. JN have a 0 to 100, Indus have 0.46 to 27. And if you notice the maximum values for all the column, you will notice that there is a huge difference in the scaling of these variables. If you have a various scaling of these variables, then you have to also understand that the scaling of all these variables should be the same. Otherwise, those variables which have a large scale, those variables will influence the target output more. But we don't want that. We want actual variable which influence the target output. Then how would you know that which input variable is influencing the target output most? If you take one column one by one, each column. Then if we calculate the correlation between the target output and the input feature, if there is high correlation, either the positive or the negative, then we can say that this is the highly correlated and there is high probability that we can predict the target output, because we need a little correlation between the input and the output. If input and output are not correlated to each other, then there is no way to predict the output. So there has to be some pattern. In the next lesson, we will learn the correlation method. We will calculate the correlation between the input to input features and input to output features. Before we calculate the correlation, we need to first install few packages. So let's go ahead and install those packages first of all. We will be needing here the tidyverse package to analyze our data set. So basically I'm gonna do here install packages. You need to just write there install pack and then press tab. It will auto complete install.packages. In that I'm gonna create here the list of packages which I want to install here. So I want here tidyverse. Then also I want here core plot, which is the correlation plot. I also want here the lattice, which we will be using for visualization. And do remember, with the tidyverse, you have already installed ggplot and dplat package. So we have also installed the mass package. There is only one package which we still need in our coming lectures. In fact, two packages. One is CA tools. This package we will be using to split our data set. Thereafter, we have here this plotly package. Just run it. Then it's going to install all these packages in your computer. Once these packages are installed in your computer, then we are going to load all these packages. There you have load tidyverse. Thereafter this library. In that library, I'm gonna do here lattice. Then library plotly. Thereafter library core plot, and then library C tools. Just run it. It's going to load all the packages in your computer. All right, that's mean in your notebook. Everything is loaded. This core plot we will be using to plot the correlation data. Let's go ahead and plot this correlation data. So first of all, we are going to get here correlation matrix that we can get with core, and then you have this Boston. Just run it. Thereafter, what would you get here? You get here this core mat. This core mat says that, sorry, this should be core mat. This correlation matrix is actually the correlation between these variables. The list of variable here is also column, and the same list of variables are also in the rows. And one more thing, if you notice there in GN, perhaps let me see, it is perhaps in charge. The charge value is quite low. If you notice, the charge values are quite low. All right, so the lowest value is here 0.07. So it means the correlation of this charge to other variables are almost negligible. This is quite low. This is quite low. But if you notice the correlation of RM, this average row number, this one is almost average correlation, but with the house price, with the house price, you will notice it has a high correlation, this one. All right, so there you have this RM. There, this RM is quite highly correlated with the target output. All right, and similarly, you will notice other variables as well there. And this median is also correlated with L stat here. This is also highly correlated, but this correlation is in negative correlation. That's mean when L stat, which is the lower status of the population, that means when the population of poor people are increasing around the house, then the house price is going to decrease. And this one was for average number of rooms. This one is the positive. That means when average number of rooms are increasing per house, then the house price is going to increase. The positive correlation means if independent variable increases, dependent variable will also increase. And negative correlation means if independent variable are increasing, then the dependent variable will decrease there. Let's go ahead and try to understand it with the plot. So for plot, we are going to use here this core plot, and in that we are going to pass our core matrix, sorry, this core mat. There I have. Then I say just run it, and then you will notice here. This core math is giving us a full matrix here. All right. So in the full matrix, these number, all right, these actually the circle shows us that if it is the darker in the blue side, that's when the blue dark color means the positive correlation. And the diagonal elements is of course 1 because the correlation with the same variable is of course will be always 1, because if you notice this charge to charge there is 1, and the correlation with any other variable is almost negligible. So this charge is the least important parameter in our data set. Thereafter, this negative correlation, that's the minus correlation. These variables, if you notice, are quite dark and red color. So these are the reddish dark color. So these reddish dark color are producing here the negative correlation. The negative correlation means when these values will increase, the dependent value will decrease. But we are interested to analyze the correlation between these variables and the target output. The target output is the median value of a house price. This one is the blue color, and the larger circle size means there is a high correlation, and this says that Rn. That's when the average number of rooms per house is high, then the house price will increase. This one is the positive. The another one we have here negative. That means it says that L stat, if a lower status of the population increases, then the house price will decrease. And thereafter we have other, like here a crime. So crime, of course, if crime increases around the house, then the price of that house will decrease. And other variables are not much important, like here you have a distance and charge. So these variables are not much important. You have another variable like index nitric oxide. So of course, if nitric oxide increases, house price will decrease. There you have here this radius and PT ratio. So of course, if PT ratio increases, that means the people to teacher ratio. The people to teacher ratio will increase when the number of teachers are less around that house. That means the house price will increase around that house. All right, perfect. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson. All right, so the first of all, now we are going to do here crime analysis in a Boston. So basically, if you remember, previously we had seen there is a column which is known as a crime column. This crime column says that what is the crime percentage happening around that city. All right. So there is error. This error is coming, and this error is a quite common error. Whenever you are working with your Jupyter notebook and you get something like this, then you can simply restart your kernel. So you need to just restart your kernel. Once you restart, then I think that this error should be gone. Let me see it once again. So still that error is coming. So to remove that error, I just want to show you intentionally. Whenever you get that type of the error, then you need to just stop your notebook, come to your Anaconda from where you had started your Jupyter notebook. You need to just stop your notebook. All right. You need to press there Control and C if you are working on Mac. Sorry, if you are working on Windows, and you need to press there Command and C if you are working on Mac. Just restart it once again. So this is going to just restart. So everything will be as it is. I don't think now there is any problem. You need to just restart this. Click on there. Thereafter, this will be gone. All right. So you can just load it. This package is already installed in our computer. I'm just running it once again so that you can see it. There the another one. There you have got the head, then this one, and thereafter just run it. All right. So we are going to do here crime analysis in the Boston. So the first of all, we are going to see here the summary. So for the summary, you can get something like this: Boston crime. You need to just write here Boston crime. This says that the minimum value of crime 0.00632. The maximum value we have here 88.97. All right. So from the correlation matrix, we had already seen that there is correlation with the crime and tax, radius, and L stat. So of course, if the lower population, the status of the lower population, I mean the lower population status is quite high in that area, then there is a possibility that the crime rate is also high. The radius and the tax rates are also high there. All right. So what we are going to do, we are going to analyze especially this tax and LSTAT. All right. So we'll be seeing that what are the effect of tax LSTAT on the crime. So for that, we are going to first plot here with the plotly. So there you have here our plotly. So there you have a plotly. In the plotly, we are going to pass here the data is Boston data set, and x is equal to, we are passing here L stat, and then we are going to see that how our crime is actually changing as L stat is changing. So the type of plot we are going to see here, the scatter plot, and then the mode we have to give here the markers so that we can get here the scatter plot. All right. So there you see here what we are getting. There you have L stat crime, and if you notice, if this L stat is increasing, then there is a possibility that the crime is also increasing. And you will notice that there will be a positive correlation between the crime and L stat. Do you see there the positive correlation? You can also verify that with the correlation matrix. There is crime, and then we have here the first row is crime and then L stat. So there is a positive correlation, and we can verify here that as L stat is increasing, the crime rate is also increasing. Let's go ahead and see how the radius is changing. All right. So the radius was actually, if you notice there, at the start of this lecture, we had here this radius. Radius was the index of accessibility to radial highways. All right. So here you need to just write here this plotly, and in the plotly, in fact, I can just copy this whole thing from there, and then I can paste it here, and at the place of y, this is going to be the crime, and at the place of x, I'm going to change here this radius. So I just want to show you that how this crime is correlated with other variable. So with the radius variable, you will notice that there is a high, all right, so there is a high crime when the radius is quite high. All right, so when the radius is quite high, then there is a high crime. So there is high crime. And when you have a smaller radius to a nearest highway, then you have a less number of crimes there. So similarly, we are also going to check here. We are also going to check it here with the taxes as well. So you need to just put here the tax. This tax says that it might take a while to plot it here. So once again with the taxes, we also get there when the taxes are high. When the taxes are high, then also there is a high crime rate. All right. So when the taxes are high, then also crime rate is also high. All right. So what we understand here that there is the high crime here. All right. So as radius is increasing, crime is also increasing. As crime, as taxes are increasing, crime also increases. As L stat increases, crime also increases. So we understand with this analysis how this crime is increasing with comparison to L stat, radius, and the taxes. In the next lesson, I'll show you where top 10%, where the top 10% crimes happen. I mean to say that how the top 10% crimes are correlated with other variable. All right. All right. Now we are going to analyze the top 10% of the crime rate. So the moreover, if I say the top 10%, that means I want to get the crime rate where the top 10 means the crime rate after 90th percentile. All right, so you can understand it like this. If you search here the quantiles, there you will get something like this. All right, so there you get if something is more than 90%, then those cases are rarest in rare. And we need to just understand here after the 90% of the quantile. All right. So we assume that it is normally distributed. Even though if it is not normally distributed, we are moreover interested in top 90%. All right. So the top 90% quantiles. So I'm not able to get here. Yeah, there you get it here. So this, let's say this one is the 90th quantile, and after this 90th quantile, these are the rarest. So we need to understand that what are the cases where the highest crime rate happens. All right, after 90% or 90 percentile. All right, so for that you need to understand it like this. If I say the summary of crime which we can get with the Boston for crime, there you get this one is the third quantile, and this one is the maximum value for a crime rate. So the third quantile means this one is 75th. All right, this one is the 75%. So the 75% of the crime rate are below than 3.75. 3.67, and the top 25% are those crime rate which are in between 3.67 to 88.97. But we are interested in the top 10. That's mean we want here the 90th quantile. So that we can get it like this: Boston crime and then 0.9. So there you get this value. So the 90% is 10.75. So their crime rate you have 10.75, something like this, and thereafter these values are highest. So these values are top 10 highest value. Now we want to filter out these values, and thereafter we will analyze these values where these values are happening. So for that we need to get here the high crime. So you can get here H crime, that's the highest one. Then we are going to get it with the subset. You remember previously I had also shown you, you can also filter out the data by using the filter as well. But here I'm going to just use the subset as well. So there you have crime, and then I say the crime is actually greater than with this value. Simply I'm going to just copy that value and then I'm going to put it here and just run it. So once I run it, and thereafter if I notice this H crime, there you will get total 51 rows. So there are 51 instances where we have the highest crime rate. And if you notice, these crime rate are greater than 10.753. Now we need to understand what are the correlation amongst these variables if we select the top 10% of the crime rate. So for that, we are going to first of all get the summary of this H crime. So the summary you can get simply like this. There you have the minimum value, and there that one is the maximum value. All right. So the summary for other statistical variables are also here. But let's go ahead and plot the same plot which we had plotted earlier. So the plot something like this. Let's say you have a plot like this, and that plot, if I plot right now, you will notice this plot there, a crime rate where you are getting, sorry, this Boston should be actually H crime. All right, so there you have greater than the 10, and now it is distributed something like this. So there still we see there is some upward trend even after this one, the top 10% quantile, top 10% of the crime rate. But moreover, it is almost you can say it's uniquely distributed between these 10 to 35 of L stat. Let's go ahead and plot here a box plot to understand it in more better way. That I say here this plot leaf, the data is equal to the Boston. So I'm just going to compare it with the Boston data set and with the current data set, which is the top 10% of the crime rate. Then I say here y equal to L stat, and I'm gonna give here the name as full Boston data, and the type of the plot which I'm going to plot here, that is the box plot. And thereafter I'm going to put here our pipeline operator. That's mean we are going to continue this operation in the next line. There I'm going to add another box plot. So this is the method to add multiple plots in a single frame. So there you have add box plot, and there I'm going to put here at what I can do, I can simply copy this whole thing and then I can paste it here, and this Boston I'm going to change it to the H crime, and this name name should be the current data set, which I say it area with 90th percentile. All right, so there percentile crime rate. There, this one is H crime. When I say the area, there if you notice, we are actually plotting it against the L stat. So the L stat is actually the percentage of the lower the status, so with the lower, sorry, with the lower status population. So the lower status population area, we are actually interested in what will be the crime rate if we plot it against the L stat. All right, perfect. So let's go ahead and just plot it, then you will understand. It says that some error is somewhere, perhaps here. That should be actually H crime. All right, so if you plot it, then you will notice there a difference is that this one is the full Boston data. In the full Boston data, you have L stat, the average L stat is somewhere here. All right, and this data is against the all right, so this data is against the crime, and this one is also with the filtered crime. So the moreover, this box plot is actually univariate. You don't have a crime data here in the axis, but if you notice, this one is the average L stat is coming somewhere here. All right, but if you notice L stat distribution for those area where crime rate is the highest, you will notice that the status of lower status of the population is quite high there. All right, so the lower status of the population is quite high there. That means this data suggests that there is possibility that crime happens more often in those areas where the people are living, the lower status people are living. All right.